Swayam Prabha. Digital India. Educated India.
So, as we discussed yesterday, that today we are going to talk about a specific type of econometric model where all or some of our explanatory variable in the right hand side that we are using is qualitative in nature. Okay. See, so far whatever econometric model we have discussed and estimated, all our explanatory variables were quantitative in nature. For example, the last model what we were discussing, that was related to saving and income, right. So, here the explanatory variable income you can easily measure by quantitatively, okay. By quantitatively you can measure the income variable. Similarly, the previous example what we are talking about, that was child mortality rate, and child mortality rate was explained by female literacy rate and per capita GNP. They are also, both the explanatory variables are quantitative in nature, all right. But sometimes we do get a situation where some of our explanatory variable becomes quantitative in nature, and then there is a specific technique required to quantify those qualitative variables, otherwise we cannot estimate our model. So, what we will do, we will first take an example to understand what type of qualitative variable we may get in our econometric model. Let us say that we are talking about wage function. We are estimating wage of an individual. Let us say that this wage of the ith individual is actually alpha plus beta 1. When we think about wage function, the first variable that comes to, first explanatory variable that comes to our mind is education, right, education. And then you might also think about another variable, which is, let us say, experience. Of the individual, okay. And now suppose you are having a research question in mind, that means you are interested to see, is there any gender discrimination in the labor market? That means with same amount of qualification and experience, whether males are getting higher salary than their female counterpart, okay. So, that means is there any gender discrimination in the market, labor market or not? That is your research interest. So, what is my third variable? The third variable is gender of the individual, ith individual and I, okay. This is our model. Now, for simplicity, what we will do, first we will remove the quantitative variables from the model and we will keep only that qualitative variable gender in the model to make it simple, right. So, we will write this wage function once again, and we are assuming that wage is actually a function of alpha plus beta 1 only, gender of the individual. Okay. Now, gender is a qualitative information, male or female, it is a qualitative information, and the moment your variable is qualitative in nature, the estimation technique what we have learned, that cannot handle this type of qualitative information included in the model. Why this is so? Because if you recall how we have defined our beta hat, we were defining our beta hat in this way. summation xi minus x bar into yi minus y bar divided by summation xi minus x bar whole square. And this x variable is actually a quantitative variable, that is what we learned. So, this particular formulation, the way we have constructed our beta, even in matrix notation also, when you define beta hat equals to x prime x inverse x prime y, even there also this x is actually a quantitative variable. Quantitative variable. So, that means both this formulation requires some number for x, so that we can estimate beta hat quantitatively, but that is not the case here. Here gender is a qualitative information. So, then what econometrician they did, they actually transformed this qualitative variable into quantitative one. So, that means they have transformed the gender variable into some quantitative one. How did they do this? So, I can convert this qualitative information, let us say alpha plus beta 1 d 1 I, or let us say simply d I plus u I. And how they have defined d I? D I is defined as let us say is defined as 1 if the ith individual is male, equals to 0 if the ith individual is female. Okay. This is how we have defined DI. So, now the qualitative information of gender is easily transformed into a quantitative one, because now it is all about 1 and 0. Okay. So, basically then this and this DI is called, this DI is actually a dummy variable. A dummy variable. Okay. It is not the original variable, but the original variable gender, which was qualitative in nature, now transformed into a quantitative one through this DI, and DI is called a dummy variable. Now, both this formulation xi minus x bar yi minus y bar divided by xi minus x bar whole square, or if you apply matrix algebra x prime x inverse x prime y, both this formula can handle this quantitative thing, because now it is all 0 and 1. Okay, 0 and 1. So, this DI is called a dummy variable, and we can now easily estimate our model, right. Now, you might be thinking of why all of a sudden 0 and 1. Actually, there is no hard and fast rule that DI should always be 0 and 1, rather this DI can always be transformed into this number. Let us say I am defining ZI equals to A plus B DI, okay, B DI. So, that means where A and B are two numbers, two constant, okay, two constant. So, now for any value of D, so that means if you put D equals to 1, then what will happen? When D equals to 1, then ZI becomes A plus B, and when D equals to 0, so that means ZI equals to A plus B when DI equals to 1 and equals to A when DI equals to 0. So, depending on which particular value you put for DI, you will get a specific value for ZI. So, that means this 0 and 1, this gets converted into, let us say A equals to 1 and B equals to 2, okay. A equals to 1 and B equals to 2. So, that means it get transformed into 1 and 3, right. So, that means 0 and 1 gets transformed into 1 and 3 depending on a specific value for A and B. Then why we are using 0 and 1? Because if you use 0 and 1, then the model becomes simple to interpret and the model becomes simple to derive certain important properties. That is the reason. So, throughout our discussion, we will use only 0 and 1 value for DI, where 1 indicates, what does 1 indicate? 1 basically indicate presence of an attribute and 0 indicates absence of an attribute. What is the attribute we are talking about? The attribute here we are talking about, let us say, the male. Okay? Male gender is the attribute. So, 1 indicates presence of that male attribute and 0 indicates absence of the male attribute, that means the person is female. You can define DI as 1 when female, 0 otherwise. There is no hard and fast rule that always male should be 1 and female should be 0. Based on the researcher's intention, the researcher can decide or the econometrician can decide which particular category you will take 0 and which particular category you will take 1, right. So, only thing what I am saying that 1 indicate presence of an attribute and 0 indicate absence of an attribute for the qualitative variable. So, here male and qualitative variable which will have two categories. Category 1 is male, this is male and this is female. Okay. So, this is 1, this is 2, this is called categories. So, we have two categories. If you think that you will define the qualitative variable in terms of 3 categories, then obviously you can add one more category, that would be, let us say, become transgender category. So, this is, let us say, 3. So, here 3 categories for the qualitative variable. Qualitative variable gender, right. So, there are 3 categories of the qualitative variable gender, right. And we have to keep one thing in mind, that number of categories, if the number of categories are 2, then you have to define, if there are n categories, you have to define n minus 1 number of dummy variable. So, here we have 2 categories, male and female, and that is why in our model we have introduced only one dummy DI. But the moment you categorize the qualitative variable gender into 3, male, female and transgender, then number of dummy variable would be 3 minus 1, 2. So, we are just keeping that part aside. So, let us try to understand from the very simple model. So, this is model number 1. We will discuss several cases of the dummy variable one by one. So, this is, let us say, model 1. Okay. We are talking about model 1. Model 1. What is model 1? There is only one qualitative variable as explanatory variable. and we have not included any other variable in the model, we are assuming that wage is a function of only the gender variable. And why we have assumed that? Because to keep the model simple, nothing else. So, here what we have to first learn is what is the interpretation of this beta 0 and beta 1 in this dummy variable model, right. So, this we will convert as beta 0 plus beta 1 di plus ui, where this di equals to 1 if male and 0 otherwise. Right, and we will try to understand what is the interpretation of beta 0 and beta 1. We have to carefully keep in mind one thing what I will mention here, the interpretation of the regression coefficients in a model involved with dummy variable are derived. There is no standard interpretation available. What I am saying, in standard econometric model, how do you generally interpret your beta 0 and beta 1? Beta 0 is interpreted as intercept and beta 1 is interpreted as slope coefficient. So, that means if it is a saving income relationship, you would interpret them as for a unit change in your income, for 1 unit change in your income, on an average your saving changes by beta 1 amount. So, that is the standard interpretation. Irrespective of whatever variable you take, your interpretation of beta 0 and beta 1, they do not change. But here in the context of dummy variable, I will write it here that interpretation of beta 0 and beta 1 are derived. So, that means you must derive the interpretation as there is no standard interpretation available. Okay? There is no standard interpretation available. So, that is the reason whenever you get a dummy variable model, first step is to derive their interpretation and then you estimate the model. Without knowing the interpretation, you should not estimate any model involving dummy variable. So, what we will do in this model also, we will first try to derive the interpretation. So, like the previous case, first thing what we have to do, we have to take expectation of wage, okay, given di equals to let us say 1 for this category equals to beta 0 plus beta 1. Okay. And what does di equals to 1 indicate? Di equals to 1 indicate the male category. That means by expectation of wage given d1i equals to 1, I can say that this beta 0 plus beta 1 actually indicates the mean wage of the male category. So, this indicates the mean wage for male, right. Similarly, expectation of wage given di equals to 0 equals to beta 0, which is mean wage of female category. Okay. And then what I said, the interpretation of beta 0 and beta 1, they are derived. So, you have to somehow derive beta 0. So, how can you derive beta 0? So, if you look at beta 0 and beta 1, so that means beta 0 is basically the mean wage of the female category. So, that means in this model, in a model involving dummy variable, the intercept has a different meaning. It is not only it is not simply the intercept, it is actually indicating the mean wage of the category for which you have not defined any dummy. So, here I have defined only one dummy di equals to 1 for the male category, but for female category I have given 0. So, that means intercept of a dummy variable model indicates mean wage of the base category. So, here female is basically the base category, that means I can say mean wage of base or benchmark category. And what is the base or benchmark category? For which you have not defined any dummy. Here I have not defined any dummy for the female category, it is 0. That is why female becomes my benchmark category or base category. Okay? So, that means intercept of this model beta 0 of this model indicates mean wage of the benchmark category, which is female. And how will you get beta 1? See, beta 1, how can you derive? Beta 1 is basically expectation of wage I given d I equals to 1 minus expectation of wage given d I equals to 0. So, that means I can say that this is beta 0 plus beta 1 minus beta 0. Okay. So, how you are deriving beta 1? Beta 1 is nothing but beta 0 plus beta 1 minus beta 0, and what is then this beta 0 plus beta 1 and beta 0? If you know, then you can easily understand what is going to be the interpretation of beta 1. What is beta 0 plus beta 1? If you look at here, see, beta 0 plus beta 1 is actually mean wage of the male category and beta 0 is the mean wage of the female category. That means beta 1 indicates the difference in mean salary between male and female. Okay. So, earlier in the standard econometric model, where beta 1 was showing the slope coefficient, that means for a unit change in income, what is the change in saving on an average, the interpretation of beta 1 is totally different here in a model involving dummy variable. And what is the interpretation now I have derived? The interpretation is the difference in mean salary between the male and the female category. So, unless you derive beta 1 in this way, you will never get the interpretation of beta 1. That is why I clearly mentioned that interpretation of beta 0 and beta 1 are all derived. Okay. So, this is how you have derived your interpretation. All right. So, this is model 1. Now, in our next case, what we will do, instead of involving only one qualitative information, let us say that I am involving, and this model, the model 1, when you have only qualitative variable in your model, that is called ANOVA model. This is ANOVA model. Okay, ANOVA model, because you are only discussing about the variation in wage in two different categories. You have not included any quantitative variable which are known as covariates. X variable or explanatory variables in explanatory model, they are also known as covariates. So, this is called ANOVA model. Why? Because you are only discussing the difference in mean salary or wage between two categories. There is no quantitative variable or covariates involved in this model. Now, suppose I am taking model 2. This is my model 2. So, what I will do in model 2, model 2 is a model where I have both qualitative and quantitative. Okay. And that model is called ANCOVA model. ANCOVA model, because I have both qualitative as well as presence of covariates makes the model ANCOVA. And how does that model look like? Again, wage equals to beta 0 plus beta 1 di plus beta 2. Let us say I am adding one quantitative variable, which is education. And why I am calling education as quantitative variable? Because you can measure education by number of years of schooling. How I am measuring education? Number of years of schooling. So, these years can be easily measured, that is why education is a quantitative variable. Okay. All right. So, that means let me write this model as beta 0 plus beta 1 di plus beta 2, let us say x1 I plus ui, where x1 I indicates education. All right. Then again what we have to do? We have to get the interpretation of beta 0, beta 1 and beta 2, and my di equals to 1 if male and 0 if female or otherwise. So, I am still assuming there are only two categories for the qualitative information gender. Okay. For the qualitative information gender, if you think more than two categories, male, female and transgender, then you have to simply include one more dummy. I am not discussing that, I will discuss in a later part of our discussion. So, now once again you have to get the interpretation beta 0, beta 1 and beta 2, right. So, expectation of wage I given d1 I equals to 1 becomes beta 0 plus beta 1 plus beta 2 xi x1 I, and expectation of wage given d1 I equals to 0, it becomes beta 0 plus beta 2 x1 I, okay, x1 I. And what is expectation of wage given d1 I equals to 1? This is basically the average wage for male, that means mean wage for male, and what is this? This is mean wage for the female, right, mean wage for the female category. Okay. All right. Now, how will you derive beta 1? That is the question. So, that means from the which function of the male category, what we see that male category's wage function is beta 0 plus beta 1, I am putting both this term into bracket, plus beta 2 x 1 I. So, that means I can easily think of that in male wage function, this is going to be the intercept and beta 2 is basically the slope. So, that means beta 0 plus beta 1 is the intercept for the male's wage function, and for the female category it is beta 0 plus beta 2 x 1 I. Okay. So, that means for male category this indicates intercept equals to beta 0 plus beta 1 and slope equals to beta 2. Similarly, here intercept equals to beta 0 and slope equals to beta 2. Okay. Now, if you compare these two, that means in terms of a simple diagram will make you, let us say in this category x axis I am measuring education and here this is wage. Okay. So, I am first plotting the male's wage function, which is this, okay, which is this, where the intercept is actually beta 0 plus beta 1, and for the female this is the wage function, this is basically beta 0. So, this is male, sorry, this is male and this is female. Okay. All right. Since these two lines are parallel, both male's wage function and female wage function, what is happening here that their slope is actually, slope becomes beta 2. Okay. Both male's wage function and female wage function, they have slope equals to beta 2, but there is a change in their intercept. While intercept for the male wage function is beta 0 plus beta 1, intercept for the female wage function is only beta 0. Then how do you get beta 0? Beta 0 equals to, how do you get it? So, it means beta 0 plus beta 1 minus sorry beta 0 sorry, this is, how do you get beta 1? Beta 1 beta 0 plus beta 1 minus, you will get beta 0. Okay. All right. And what is this? Beta 0 plus beta 1 is actually the intercept of the male category's wage function, and beta 0, if you look at, is the intercept for the female categories. So, that means I can say that this beta 1, what I have included in the model, this beta 1 is actually called differential intercept. What I am saying? So, that means this becomes the differential intercept. differential intercept. Okay. All right. So, how do you derive the interpretation? So, beta 0 is actually beta 0 becomes from this model, it is very clear that when you put D1 I equals to 0, then females categories intercept is beta 0 and males categories intercept, it is when you put D1 I equals to 1, it becomes beta 0 plus beta 1, and the difference between these two intercept is beta 1. That is why the interpretation of beta 1 in this model is called differential intercept. Okay, is differential intercept, and beta 0 as usual, that is the intercept of the base category, because you have, if you have put D1 I equals to 0, that becomes beta 0 plus beta 2 x1 I. So, that means the beta 0 becomes the intercept for the male female category. Okay, and beta 1 is the differential intercept, very simple to understand. Okay. So, the interpretation of beta 1 is the differential intercept in this model, and both male and female's wage function is having slope equals to beta 2. That means there is no change in slope.